Welcome back to one of our other cloud architecture videos. In this one, it's going to be on Kubernetes. In this video, I am going to set up a full local Kubernetes development environment on macOS using Minikube, Docker, Helm, and an optional production-grade monitoring stack with Prometheus and Grafana. Also, I'm going to deploy a production-grade style Neo4j cluster on Kubernetes using Minikube. The goal is not just to run Neo4j, but to demonstrate how a real platform engineering workflow looks using Helm, stateful sets, persistent volumes, and operational tools like backups and ingress. This setup mirrors what you would see in a real cloud-native environment, but runs entirely on your laptop. Also, this setup mirrors what you see in a real distributed system, a stateful database running inside a Kubernetes managed environment with persistence and operational control. As usual, we'll do a walkthrough. Do some environmental checks with these just to make sure you have sufficient drives, etc. For this case, I already checked, so I'm good. I won't be doing these. And Darwin and processor AMD 64. We're going to use this version, Kubernetes and Helm. We're going to use this version. The Kubernetes version we're really going to use is this one here. I just have some extra variables there. And we'll be add-ons we'll be adding when we install the Kubernetes. We're going to be including these add-ons. I declared this set to show you a few drivers that are available and talk a little bit about this because this will impact how you decide what driver to use and what environment. Here I have 4 drivers: Commute2, Docker, VirtualBox, HyperKit. And Docker runs Kubernetes inside Docker container. It's most common, easiest, fast startup, requires Docker running. Kimu 2 use it's lightweight virtual machine and virtualization. Uses Kimu, works well on Linux, and but slower than Docker. VirtualBox uses VirtualBox VM, older, widely supported, heavier, and slower than Docker. HyperKit, macOS only, native macOS hypervisor, faster than VirtualBox on Mac, mostly replaced by Docker driver. Let's talk about when to choose each mini driver. For the Docker driver, use when you already have Docker installed. You want fast startup and slow overhead. You are doing day-to-day development or learning, like in this case. You are simulating cloud-native environments since most workloads are container-based. Why? No full virtual machine VM, lighter and faster. Easy integration with your local images. Docker build matches how apps run in real cluster. The limitation, less isolation than a VM. Some low-level networking or kernel features aren't identical to real cluster, and it's best for local development, CI pipelines, quick testing. The VirtualBox driver, use that when Docker is not available or restricted. You need a fully isolated VM environment working on older system or standardized enterprise setup. Why? Full virtual machine, closer to real node behavior, more predictable networking than Docker in some cases. The downside, however, is it's slower startup, higher memory CPU usage, but it's best for legacy environments, training labs, strict isolation requirements. Kimo 2 driver, this is Linux focused. And you use this when you are on Linux without Docker or don't want Docker. You want a lightweight VM alternative to run in an environment where KVM is available. Why more flexible and scriptable than the VirtualBox option? It works well in headless server environment. The downside though is setup can be more complex, still slower than Docker, but best for Linux, power user, server environment, automation setup. HyperKit, that's a macOS thing. You use that when on macOS and not using Docker desktop. You want a native hypervisor-based VM, and why do you use this? You use it on macOS native virtualization. This is historically faster um, than VirtualBox and Mac. But the downside is largely replaced by Docker driver today, less commonly used now, but best for macOS setup without Docker or lightweight VM um, preference. So let's continue with the coding setup here. Okay, we'll just define some variables for the networking, CPU, Grafana default port, and some little goodies I like to use. Okay, so we'll run our Grafana on this port, and we'll deploy one app here. I'm going to deploy two, but this is two of the apps that will be deployed. Minikube disk, I'm using 10 gig, and I'm going to use a 2 CPU memory. So I tuned these to these values after some testing based upon what I had. What I'm doing here, I'm not using my local drive because I didn't have enough space. So I mounted this OWC Express, and I am setting Minikube up to write its data to that drive. Okay, and to do that, to allow it to write to that drive, I already mounted that drive to um, right here. So and I'm using Kimo2. Minikube creates a VM disk image file like qcow2, something like that. That file is then stored on the Minikube home. By relocating the Minikube home, I relocate the VM disk, all container images, Kubernetes state. VM disk image, container images, Kubernetes data, logs, etc. Will all live under this volume. And I am going to run this in a script format, so allow me to do a clean, monitor, allow me some flexibility when doing deploy. So when we run this script, we can say, clean the environment, CI mode, or monitoring. So some helper functions that I created just gonna add a few helper functions. Um, we're gonna be using several commands later on, so I'm going to evaluate each of these commands, and I want to also wait for Docker to start up, and also socket vnet. Okay, so check socket. You don't really use this one, but I'll keep it there. And we're going to include um, Grafana. port forwarding. So we're gonna do some port forwarding for the Grafana because I'm on a single Mac here.